GigaMe Instructor Live Sessions. Today, we take a session on microservice architecture in system design.
Yeah, actually, good morning.
Yeah. So today the session will be like system design or AWS, like Shivshankar mentioned
System design
AWS.
topic. So, what is scalable backend? Do you know what is a scalable backend?
Scalable as in, when we actually add servers and deploy the code on different multiple servers, then we are actually scaling the backend APIs.
So, did you get any chance to scale your application?
No, actually, only once when I was at DBS Bank, we just added a load balancer. So that was that. Because most of my applications which I mean, at least the last two projects which I worked, it was the users were less actually. It was not a huge user base. So just once we added a load balancer and we deployed on
Mm-hmm.
two servers, and we were just monitoring those two. That's all. So it was not very scalable.
Hmm. So, let's say your requirement comes to design some scalable backend architecture for large user base. Okay,
Mm.
then and still you are following monolith application architecture, or in your current project it's a microservices.
It was microservices.
Okay, it's microservices by architecture, right?
Yes.
So did you create API gateway as well?
API gateway, we didn't have API gateway. We
Then
just used to
how?
deploy. We just used to deploy in the PCF and the front end from Angular. We used it actually.
So Angular team calling your API? I mean,
We just used a HTTP request and we had interceptors, etc.
no, that's fine. I mean, let's say you have two microservices, okay? User microservice or product microservice, okay?
No, actually, I was responsible. No, we created only REST APIs, so I did not create like um, the overall architecture was microservices, but I was only responsible for creating like one service kind of thing, and we interacted with only one service.
Mm-hmm. Okay, cool. So, see, in system design, nowadays the most important topics are, I mean, the question also get from this microservice based architecture. Not only you just know the definition of microservice, and I know a microservice, no. In microservice architecture, there are lots of topics inside this. How you scale your microservice, how to deploy your different microservices, what strategy you follow to use database. Is it single database for each service, or is it common database for each, I mean, for each service? And then how, let's say, in your project, I don't know how much complexity of your functionality is, but let's say in real time, if you have some complex functionality, like when your one service is dependent on other service, then how you'll manage the transaction management on those two services. Are you getting my point?
Oh yeah.
So see, microservices very important. I mean, nowadays people just developing microservices, but before developing, you have to think like, what is your business domain? Do you really need microservice? Do you really need monolith architecture? If you can complete any task with monolith application, then there is no need of microservices. But if you think there is
Okay.
a, yes, I want to develop something scalable architecture. First of all, microservices architecture, right? So here topic is designing a scalable backend architecture using Spring Boot microservices. So what is monolith and microservice difference between these two architecture? Any idea?
In monolithic, all the I mean the services, everything will be in a single code base,
Mm-hmm.
and they are tightly coupled.
Mm-hmm.
So whereas in microservices they'll be loosely coupled, and we'll create independent services, and so yeah, those are the major difference.
And other differences?
And also it'll lead to faster deployment. We don't have to deploy, even the build and deploy will be faster in case of microservices, because only the service in which we are making the changes, we can just deploy them and make the change, build and deploy in the production. Whereas in the monolithic, we have to build the whole code and then we have to deploy. Um, so in the monolithic,
Yes,
it takes faster build time, and I mean slower build time, and also it's very heavy deployment.
correct. Yes. So yeah, simply it's already given here, monolith architecture and microservice. Why we jump from monolith architecture to microservice architecture? Because of these reason. One issue is with scalability. Monolith application scale as a single unit, meaning all component must be scaled together, even if require less resources or whatever in those cases. So this can lead to inefficient resource allocation. And second is maintainability. If you work with monolith architecture, so all components will be tightly coupled. So making changes to, let's say, if you one part of the application can have unintended consequences of other parts of the application. And always you need to do integration testing for each thing. I mean, even if you change for, let's say, login module, you have to integrate or do integration testing or regression testing for each unit. That's the main issue for monolith. And then yeah, deployment complexity obviously is there, because deploying update to a monolith application requires deploying the entire application, even if only a small part has changed. It can lead to longer deployment times and increase the risk of errors. Then most important point is the technology diversity we have in microservices. But in monolith, mostly we use single technology stack. So it's limiting the flexibility of choosing the best tools and technology for each component of the application. If you are good in Spring Boot or in Spring Boot, then the monolith application could only be developed using Spring Boot technology. But in case of microservice, no. I mean, if you know Python, you can develop one service in Python. If you know Spring Boot, you can develop one service in Spring Boot. If you know Node.js, one service you can develop in Node.js. So these are called technology diversity in microservice terms. So when we choose microservices, it means we are addressing these challenges which comes under the monolith architecture. So in microservice architecture, addresses the challenges by breaking the application into smaller, more manageable services. Each service is responsible for a specific business function and can be developed, deployed, and scaled independently. This brings several benefits. Like, what are those benefits? First one is already you mentioned, like scalability. Yes, microservices allow for fine-grained scalable, where only parts of application that requires more resource can be scaled independently. So this leads to more efficient resource utilization and cost saving, obviously, because you are working for a project and product, so important part of cost saving. Modularity. With services decoupled from each other, changes to one service do not affect others, making the code base easier to maintain and update. And developers can focus on specific services without needing to understand the entire application. Then here also we have deployment flexibility. Microservice can be deployed independently, allowing for faster and more frequent updates. And nowadays people follow the agile methodology. So for the agile methodology, Scrum, I think deployment is very important. This enables organization to adopt continuous integration and continuous deployment practices, leading to faster time to market and improve agility. Technology diversity, I already explained you. Technology, each microservice can be used the most appropriate technology stack for its specific requirements. This allow organization to leverage the best tools and technology for its service, leading to improved performance, scalability, and resilience. So overall, if you compare, monolith architecture have their place. Microservice architecture offer greater scalability, flexibility, and maintainability, making them an attractive choice for modern complex application. Now, you can create the microservices with different tech stack, but if you know Java Spring Boot, that's very good. It's this documentation is only written for Java Spring Boot only. So you can just go through it and try to create different microservices by your own. So if you know Spring Boot, you know how to get project and all, which is Spring Starter and everything. Just create it. So here, these are the key principles guiding design. Basically, if to follow while creating the microservices using a Spring Boot, like decomposition, service autonomy, resilience, API first design, containerization, orchestration tool you have to develop like Kubernetes to easily deploy those services on container. So Spring Boot is a framework for building microservices, promoting scalability and resilience, following core principles like dog decomposition, autonomy, resilience, API first design, containerization, and orchestration tool. So here it's all things high level. If you just let's say one example, the high level architecture could be, let's say I have one e-commerce application. So for e-commerce application, I need the user service to manage the user authentication, registration, and profile management. If I need profile service, this profile service will handle the product catalog, inventory management, product related operations. Then we have order service responsible for order management and processing all those orders and handling the payment. So these services you have to create for a e-commerce application, and gateway service act as an API gateway for external client routing request and transforming the request response also. Then these 2 points, dependency injections, understanding dependency injection, very important because if you come from a Spring background, you know how to create the bin definition, injection type, inversion of control mechanism, dependency resolution, scopes and all. Now, let's say you created 4 microservices and you have the routes ready. Now, if you have routes ready for all microservices, then you need what? You need API gateway as well, right? Because API gateway will only configure your all microservices in common point. So API gateway basically a crucial component in modern microservice architecture. It acts as a single entry point for client to access various microservice, handling tasks such as routing, load balancing, authentication, authorization, rate limiting, and more. So API gateways like a Spring in a Spring Boot, API gateways like Netflix Joule are very popular in choice.
So I have not done with the API gateway actually. So, but we created Spring Boot REST services, and they said, and it's actually a microservice based architecture. So, if then that is the case, it's not possible to do without API gateway, is it?
See, it's not, I say like not possible, but when you develop something as a scalable basis, so you need API gateway because API gateway is not only forward your routes. API gateway can transform and your request body and response data as well. You mostly see in real-time application when you open the Zomato or something, any food online food ordering system in desktop app or mobile app, you will get different response. Did you observe?
Oh no, I've not observed. Like what sort of different response you're saying? Like,
Maybe some other data you will get in desktop app, in mobile app. There will, because see, mobile app is a small layout architecture, right? There you will get different response. Like let's say
mm,
product information. I'm not getting full product information because I need to display only minimal information in mobile app. So these response transformation also done by API gateway itself. API
okay.
gateway can also do request transformation. If you are sending one request, and then inside the API gateway, they will call the authentication things and all. After batching the authentication token, everything, they will forward the request to other services. Otherwise, they will redirect to fallback services. So these things done by API gateway. That's why API gateway is called entry point of your application. I know you develop REST API. In REST API, you don't think we need API gateway, but if you have multiple services, 10 microservices, okay, let's say you have 10 microservices, you mean you will call each service from the Angular application like this, HTTP localhost 8080 slash product, HTTP localhost 8081 slash orders, like this you will call from the Angular application. Is it good
Yeah,
practice?
Okay.
It means from Angular application, you will hit only one entry gate, like something like this: HTTP localhost API gateway slash dot something. Now it's a job of API gateway to redirect those routes to different services or
Okay.
transform. See, that's why it's a basic overview. If you go for here, let me go API gateway. See clients here. Basic overview of a design system architecture using Spring Cloud Gateway is client represents the user or application making request to system. Then Spring Cloud Gateway acts as API gateway responsible for receiving incoming requests from clients and routing them to appropriate microservices. Then microservices, what? Individual service that basically perform a specific task in the application. These clouds include services for user authentication, data retrieval, processing, etc. And then database. Let me show you the diagram of API gateway, how this looks. See this. This is very good site to read
Okay.
about microservice region pattern. So here context.
Microservices.io.
Yes, it's very good website to read all the topics of microservices.
Okay.
So let's imagine you are building an online store that uses microservice architecture pattern and that you are implementing the product details page. You need to develop multiple versions of the product details user interface. HTML5, JavaScript based UI for desktop and mobile browsers. HTML is generated by a server-side web application. Native Android and iPhone clients. These clients interact with the server via REST APIs. So, in addition, the online store must expose product details via REST API for use by third-party applications. A product details UI can display a lot of information about a product, for example, Amazon.com or any poster in action displays. Basic information about the book, such as title, author price, your purchase history, availability, buying options, other items, and all. Since the online store uses the microservice architecture pattern, the product details data is displayed over multiple services. For example, product info service, pricing service, order service, inventory service, review service. Okay. Consequently, the code that displays the product details needs to fetch the information from all these services. Now, problem, what is problem is, how do the client of a microservice based application access individual service? How you will access product info, pricing, order, inventory, and review service like this. So the guarantee of the APIs provided by microservice is often different than what a client needs. Microservice typically provide fine-grained APIs, which means that client need to interact with multiple services. For example, I described above. Okay. So different clients need different data. For example, a desktop browser version of a product details page desktop is typically more elaborate than the mobile version. Yes, you obviously just check in your mobile. Today, just check, open any application in mobile. Let's say open Amazon application in mobile. Okay. And same Amazon
Mm.
application in desktop. You will get difference. Okay.
Okay.
Just today try, you can give it a try.
So I thought that was because, we used to have those media queries and we used to show different um, UI for mobile, desktop, and also in the backend services based on the stream, whether it is desktop or mobile, we got different functionalities. So I thought
No,
it's
so
like
who
that.
will decide? So who will decide if request is coming from this client or that client? Who will decide?
Okay, that is a API gateway. Okay.
Yes, here is the rule of API gateway only.
Okay.
Because product details, because you will not write two API, right? One for mobile API, one for desktop API, isn't it?
Yeah.
So here network performance is different for different types of clients. For example, a mobile network is typically much slower and has much higher latency than non-mobile network. And of course, any WAN is much slower than a LAN. This means that a native mobile client uses network that has very different performance characteristic than a LAN used by server-side application. The server-side web application can make multiple requests to backend service without impacting the user experience because it's a server. They can make internally multiple requests. The number of service instance and their locations host per post changes dynamically. Partitioning into services can change over time and should be hidden from the client. Yes, when you partition your services, this should be hidden from the end user, I mean the client here. Now, solution is what? Implement an API gateway that is the single entry point for all clients. The API gateway handles requests in one of two ways. Some requests are simply proxied or routed to the appropriate service. It handles other requests by fanning out the multiple services. So see here, we have view model controller thing, web application native app sending a request to API gateway. Now its API gateway job is to transfer this request to appropriate service like product info service, recommendation service, and review service. But first it will interact with the API gateway here. So API gateway sit as a gate, okay, behind the all microservices.
Okay.
Now, see here also, if you see variation backends for front ends. If we have web application, mobile app, third party applications, so different API gateway, web app API gateway, mobile API gateway, public API gateway. Then mobile web app API gateway goes to REST or catalog service. Mobile API gateway again from here there also you can talk. It's not like you can create on single API gateway also. But if you want more again kind of scalable, create different API gateway like this. See this architecture of this front end, back end for front ends. So resulting context will what? If you use API gateway, what the following benefits you'll get? So first insulates the client from how the application is partitioned into microservices. Insulates the clients from the problem of determining the locations of service instances. Provides the optimal API for each client. Reduce the number of requests and round trips, for example, and the API gateway enables client to retrieve data from multiple services with a single round trip. Fewer requests also means less overhead and improve the user experience. An API gateway is essential for mobile applications. Simplify the client by moving logic for calling multiple service from client to API gateway. This also we can do. Now, yeah,
So
drawbacks.
basically, what we are saying is API gateway can also call multiple your services and combine the response, and
Yes,
that's what
that's
you're
why
saying, right?
it can transform the response. It can transform the request body as well.
Okay. So in the front end, we have something called interceptors, right? HTTP intercepts. Is it similar to a API gateway, or that is just
No, interceptor means what? You, while making the request, okay, while making the request, you are intercepting something inside your request body. Let's say if you want to add headers in each request, how you will handle it? You will write one common function, interceptor function, right? That generally
okay?
comes inside the Angular as how to write HTTP interceptors.
Yeah.
Then obviously if you implementing something large scale, those have some drawbacks as well, like here increase the complexity. Yes, again API gateway is another service, so API gateway is it another moving part that must be developed, deployed, and managed, because it's a service again, so you have to develop it, deploy it, and manage it. Then only your application will be fully functional. Increase the response time due to the additional network hop through the API gateway. However, for most applications, the cost of an extra round trip is insignificant. Yes, sometimes it leads to be insignificant response time because they has to call multiple services to get the proper response to display in the UI. So these are a little bit drawbacks while implementing the API gateway. Then issues how implement the API gateway. An event-driven the reactive approach is best if if it is must scale to handle high loads on the JVM, Neo-based libraries such as Native, Spring Reactor, and uh, makes sense. Node.js is another option. See, nowadays, what is happening? It's a debate going on. Like, if you use API gateway, we have the another approach also available. What approach? Event-driven approach. Did you hear the event-driven approach?
Yeah, I've heard of event-driven approach, but I thought event-driven approach is more like say React or Angular, we have a lot of event listeners, and based on that.
Yeah, no, that's fine. But in microservices, in backend world, event-driven means what? You means you are following messaging queue system.
Okay, like Kafka, etc.
Yes, yeah, those things. Because for asynchronous call, these messaging queue system are useful. I mean, if you make any request to, let's say you did payment. After payment, you want to display the success message like your payment has been successfully. So those message topics you can put inside the Kafka, and whoever the consumer available, those consumer can consume those messages. So it's not block your code or other functionalities. Once you payment done, you can put those topics into the Kafka, and let's say my user service available. So if user service is a consumer, user service can consume those messages or by order from the Kafka queue, even from RabbitMQ also. Not only Kafka, these two popular messaging system are RabbitMQ and KafkaMQ. Yes, but if, while implementing these things, the complexity as you will get overhead of kind of do configuration, set up the server of RabbitMQ, set up the servers of Kafka server, create the consumer, create the topics, then create the producers. These things are overhead, but to create the I would say like more complex and more scalable application, you need these things.
Okay. So, why would we? I mean, what will the Rabbit MQ and Kafka will do? Like in case of payment completion, like it will get the response from the payment server, and then it will uh, return the response whether it is successful or
Kafka
not.
and
Is it whether the pay?
RabbitMQ, you see, Kafka and RabbitMQ are mostly for, asynchronous. Let's say I did my payment, okay? Payment
Okay.
successfully done, and user can then browse other orders also, right? User can browse
Yeah.
it. But who will take care to sending those messages? Because I will come from the order service. Yes?
Okay.
Then who will take the responsibility of sending messages? So in this case, people integrating the message queue, whatever the functionality you want to execute it, places inside the queue, message queue, and those message queue, then you need to design the consumer. Consumer can access those queue one by one and get those response or get those functionality done. Important thing is queues, these massive queues work in try and kind of fail approach. If it is fail, it will try once again. Okay. And in order, so you can easily track the masses order also. If because in queue message will be in order only, so you'll receive those message in order itself. So let me open here. Should be we have something called messaging queue system. How to implement those and all. 1 second. Should be there. Event-driven architecture here. Let's select this. So designing a real-time messaging system with Kafka and Spring Boot can be highly beneficial for various real-time use cases. Kafka is a distributed streaming platform that provides scalable, fault-tolerant messaging and is well suited for real-time messaging scenarios. Spring Boot, on the other hand, is a popular Java framework for building microservices and can integrate seamlessly with Kafka for developing a real-time application. So let's say scaling to 100 million active users is significant milestone requiring robust infrastructure and efficient data processing mechanism. Apache Kafka is powerful distributed streaming platform that can play a crucial role in achieving this scale. Scaling a platform to accommodate 100 million active users is monumental achievement, okay, in today's digital landscape, market by competitive and in ever-growing user experience. So why the core of Kafka is what? Kafka is a distributed event streaming platform that excels in handling massive volume of data in real time. Originally developed by LinkedIn, Kafka has emerged as the de facto standard for building resilient high throughput and data pipelines powering some of the world's largest, most dynamic application. Let me go to main thing here. What is architecture of the Kafka? So we need producers, we need cluster, we need topic partitioning, we need consumer groups and consumer as well. In small things like you need only producer and Kafka cluster and topic and consumer all itself. That's also fine. But what is producer here? Producer means any application who generates data, such as user interaction,
Okay.
logs, system events, produced in Kafka, producer Kafka. Ensure that producers are optimized for high throughput and low latency data ingestions. Then we need topic partitioning. Partition topics to distribute the load evenly across brokers. This allows parallel processing and improves throughput. Then we need consumers. Consumers means what? Implementing consumer application that process data from the Kafka topics efficiently. These applications may perform various tasks like real-time analytics, monitoring, or feeding data into the downstream systems. So for this, we need this message queue. In AWS, tell me in the AWS what we use to write for queue system, messaging queue system. Do you know SQS?
No.
In AWS, we have the SQS service. Through SQS, if I give you real-time application,
Mm.
let's say you are developing IoT based application. IoT means Internet of Things, right? Where
Yeah.
where IoT devices basically through sensors read the data, and that data you need to store in SQS first, right?
Okay.
From SQS, you will fetch the data and manipulate and display the analytics report in your dashboard.
Okay.
So these queues are not mostly, I mean, best example of these queues to use is IoT based application where sensor is keep resensing data and reading data continuously, any sensor devices. And
Mm.
those data is not in the correct format. Those data are called raw format data because I don't know how hardware devices will read the data, right? These are raw
Yeah.
data. That raw data I will push into the SQS, and from SQS I'll pull it and I will transform my raw data to meaningful information, and then I will store those data into the system to create the recommendation system something. Simple example I'm giving you. Let's say I'm developing IoT application for plants. Okay. Hmm?
Mm.
So I will integrate the IoT device, hardware device to read the data from the plants through sensors. What data I need? Let's say life of plants, which kind of seed is it, species is it. I will read those information in raw format. I will send it to SQS. Then I will create one application like Spring Boot, Node.js, any application. Those application will talk to SQS, fetch the raw data one by one in order which they sent, and then from that data I will create the meaningful information. I mean, meaningful information means I will create some format of data like the model which I prepare for MySQL, MongoDB, whatever. And those data I will store in database, and from that database I will populate this to UI to display the analytics of about a plants or anything. In this way,
So from basically here, the producer is actually those sensors. The sensors
correct,
will produce the data and it will feed into the Kafka or
correct.
SQS. And from SQS, the database will be the consumer.
Not database, from SQS, any node application, any Python application is consumer. How
Okay, any
database
Python
can directly
applications.
talk? The database directly cannot talk na, to SQS, right?
Okay, so
We need
any
the
Python application will be the so
yeah,
like
any
jobs, that kind of thing they'll run, no, in Kafka. That
yes, definitely, yeah. So I just given the brief info how I mean these application works. Okay,
okay.
I have worked on the IoT based applications where I implemented the SQS messaging system AWS. This IoT based application completely
Okay.
from scratch. I developed this SQS, not sensor because sensor department was handled by IoT team. I mean hardware team. They have developed the devices with the sensors, but reading data from sensors, I used to talk with the hardware team. Hey, your device is up or not in your let's say fields areas or whatever open plots area. They are keep messaging me, yes, my devices are on and it's reading the data now. You can see the data inside the SQS. Yes, I was able to see those data and fetching data from Node.js application, creating the schema models in saving the MySQL or MongoDB, then populating same data to user dashboard to get the analytics about those IoT devices.
Okay. But so in my case, actually, I worked on some supply chain, data analytics application.
Mhm.
So there they used to load the data using Kafka into the database, and we used to get the data like through APIs and show as a dashboards.
Yeah, so
So
if you loading data through Kafka dashboard, to the directly Kafka to database.
yeah, I mean, I was not part of that this one. I was only accessing data from the database, but right now in the interviews and all, they're asking for Kafka, right? So there was Kafka in the application. So I was not I just know that there was an independent Kafka developer who used to run jobs that will load the data into the database.
Yeah, could be then. I mean, if you not integrating any application to Kafka, then yeah, Kafka maybe they have configured to read directly to database and pull the data to database or whatever, push the data in database. Yes, that also you can do. It depends application to application. If you're handling through application, then you have to create consumer, producer. Producer will also run application, and consumer will also run application.
Okay, so in this case, there won't be a consumer application, is it? It'll just push data to database.
That's only called consumer. Consumer means what? Whoever, whatever entity is trying to consume the things from the Kafka queue. That's it.
So here, the consumer is a database, or there should be an application to like a job to
It
actually.
depends. If you are developing application, then consumer is application in your case. If you're developing database, if you are pulling data directly to database, then database you're a consumer in your case.
Okay,
मतलब कौन consume कर right depends like who is consuming the things right.
okay.
So you can
And in case of the payment systems, you are saying, right, they'll use message queues. So how do they use message queues in case of payment systems?
yeah so let's say simple see after payment done right after payment done you will publish na some message you will send notification yes or no to GPay.
Yeah,
Sometimes you will feel after doing the payment in GPay payment done but you're not getting the notifications right.
yeah.
Why so? Because maybe the consumer didn't pull the data from the Kafka queue or any RabbitMQ. When they available, they pull it and display the notification system. We have two services here. One is payment service, one is notification service. So payment service will push the message inside the queue and the notification service is up. Notification service start pulling the messages from the queue. This time it is consumer, okay?
Okay.
Then you will.
So there'll be like a try and fail approach in message queue, right? So in the message queue, we can configure to retry if the we
Yes,
can.
obviously. Correct, correct. Everything you can do, yes.
Okay.
See here only, if you see the example they have given, you have to read about it. Okay. Or do one thing. If you want to get deep knowledge on now, create two
Mm.
microservice today. Okay.
Okay. Okay.
I'm giving you to let me show you.
Like because they're asking whether how they've asked me like how I do this try and what sort of design patterns I used, how do I do the retry mechanism, and also for Kafka they are asking like how two microservices will interact with each other, that kind of questions. So
Understand. Yes, yes, totally understand. So today create two microservice, simple microservice I'm giving you. One is user microservice, okay,
okay,
and one is let's say product microservice. And let's get one notification also. Create three microservice user product microservices. Okay. Inside the
okay,
product microservice, just write dummy order service, order means API to place an order. And after placing an order, push the message inside the Kafka. And yeah, integrate the Kafka also. Integrate, try to integrate Kafka. If you struggle, but first try it. Integrate Kafka or any RabbitMQ, Kafka with topics, with consumer, producer. So from here, you have to send the message to Kafka. It means it is a producer.
Okay.
And here you have to receive the message, it means consumer. And after receiving this message, display to UI also. Means it means from Angular application, you will call the notification microservice to get the notification from the consumer, from the Kafka queue. Okay. Just simple. Today, give a try. Create 3 microservice, user microservice, product microservice, notification microservice, and integrate the Kafka by yourself. Search it and integrate it. Okay?
So basically, what will the user microservice do? The product microservice will place an order, and that order will go to the producer, that is the Kafka message. Then once the order is placed, say I'm interacting with some dummy third-party API and the result is processed, then I'm feeding it to a notification service consumer, right?
Yes.
Okay.
Basically, here I have given the user. Currently, in this context, you don't need even the user also. For demo purpose, you can just display the products and you can click on the add products button and product can be ordered successfully. From there, you can push the message to producers directly.
Okay.
Okay?
Okay.
Just simple assignment I've given you. Try with, take your
Mm.
time, 2 days, 3 days, create
Okay.
this. You will get like the flow, how actually Kafka works and what is the use case of Kafka then.
Okay.
Okay. And once you're done now, push your code in GitHub and share to GitHub link to me also. I'll review your
Yeah.
change.
Okay. Okay.
Okay. Then let's meet tomorrow. Okay. Anything else?
No.
Yeah. First complete this assignment and share the GitHub link to me by mail.
And also one more thing, do you have any references where I can refer how to create,
Sure, sure. Yeah. Let
user?
me share it. After the call, I will share it by mail. Okay.
Okay, sure.
Sure. Yep. Thank you.
Thank you so much.
Thanks for watching. Want to stay updated and learn more? Follow us on social media.